Hi, everybody. This is Mrs. Irvin. I'm here to go through the notes 7.3 day 2 with you. So to start, we're going to do a quick review. In number 1, what is the measure of angle 1? Well, since angle 1 is a central angle and it intercepts the arc, that's 132 degrees, the measure of angle 1 is equal to 132 degrees. In question number 2, we want to know what is the measure of arc ABC. So I always recommend that it's helpful to trace what you're looking for. So there's arc ABC. Now in this problem, we have a central angle of 50 degrees, which means that arc AC is 50 degrees. Now if a full circle is 360 degrees, I can subtract off arc AC, which is 50, and I have 310 degrees for the measure of arc ABC. Right, next, in number 3, I want to know, is arc AB congruent to arc CD? So remember, congruent means same length, same measure. If I have a central angle of 65 degrees, the measure of arc DC is 65 degrees. And the measure of arc AB is 65 degrees. However, when we talk about congruent segments, we know that they have the same length. If I look at my two arcs in which I'm trying to determine if they are congruent, it's very clear that they have different arc length. Now, arcs can only be congruent if they are in the same or congruent circles. So since arc AB and arc CD are neither in the same nor congruent circles, I would say that arc AB is not congruent to arc CD. So that third problem here in our quick review warm-up leads us into some theorems. So the 6 theorems are summarized here for us. So thankfully, we don't need to write them all out. First says, if 2 central angles of a circle or of congruent circles are congruent, then their intercepted arcs are congruent. Well, that makes sense because central angles are going to equal their arc. And if the central angles are congruent, then the arcs have to be congruent. If 2 arcs of a circle or of congruent circles are congruent, then their central angles are congruent. So these first 2 theorems go together. They are converses of each other. My third theorem states, if 2 central angles of a circle or of congruent circles are congruent, then their chords are congruent. So these chords are going to be joining the endpoints of the sides of the angle. And we'll see that in a diagram momentarily. Now, conversely, if 2 chords of a circle or of congruent circles are congruent, then their central angles are congruent. Okay, so we're just doing the opposite if-then statement. Finally, my last 2 theorems state if 2 arcs of a circle or of a congruent circle are congruent, then their corresponding chords are congruent. So now we have arcs and chords. And again, the converse of that theorem states if 2 chords of a circle or of a congruent circle are congruent, then their corresponding arcs are congruent. So if we're given congruent chords, then we have congruent arcs. So to sum that all up, super duper important right here. If we have congruent central angles, then we have congruent intercepted arcs and congruent corresponding chords. You'll notice with these little arrows that we have, means it works either way. So we can go forwards or backwards on there. You can have any pair, so congruent intercepted arcs or congruent corresponding chords, and you can lead to the other examples as well. So let's see how this is going to work in the first example. Okay, in example 1, it says, if angle 1 is congruent to angle 2, so I have a pair of congruent central angles, then segment AB is congruent to segment CD. Okay, those are the corresponding chords of the circle connecting the endpoints of the sides of my angle. And arc AB is congruent to arc CD. I don't know why the arcs don't show up. There we go. Now in my second part, part B, if I'm given the congruent chords, segment AB congruent to segment CD, then arc AB is congruent to arc CD, and angle 1 is congruent to angle 2. Finally, if I'm given the congruent arcs AB and CD, then chord AB is congruent to chord CD, and angle 1 is still congruent to angle 2. Okay, so this is just a visual of our 6 theorems. So if you do need to see what those theorems mean, A, B, and C in example 1 will help you. Now in example 2, we need to determine whether each statement is true or false. We throw in some arcs here for us. They should be in your packet, but for whatever reason, they're not in the PDFs. Okay. What we're given here is circle O. We also need to have point B and point C. Yikes. Our central angles that we are given at point O are right angles, so those are 90 degrees. Now, if those two central angles are 90 degrees, then I know their intercepted arcs are also 90 degrees. So part A, true or false, the measure of arc DE equals 90 degrees. Well, of course, that's true. We've already marked that that intercepted arc is 90 degrees. Part B, the measure of arc AC is 90 degrees. And again, that is true. It is an intercepted arc of a central angle that measures 90 degrees as well. Next, arc DF is congruent to arc DE. Those two arcs are both within the smaller circle O, and since they are both part of the smaller circle O, the same circle, then have the same measure, I can say that those are congruent. Next, I have arc DE congruent to arc AC. Arc DE congruent to arc AC. This is false. Okay, now this is going to be false because while they are both measuring 90 degrees, they are not within the same or congruent circles. And finally, part E, we have arc AC congruent to arc CB. This, of course, is also true. They are both two arcs measuring 90 degrees within the same circle. Okay. Example 3. We're given 3 pieces of information here. We're given circle O, so I know that is the center of my circle. The measure of arc AD is going to be 120 degrees. And the length of segment AD is 10 root 3. So we want to make sure that we mark that on our diagram as well. And arc AD is 120 degrees. Okay, so that's our given information. Define some arcs, just arc BC. Okay, so we're finding the measure of angle AOD. Now, angle AOD is this angle right here. It's a central angle that intercepts arc AD, so it's 120 degrees since the central angle is equal to the measure of its intercepted arc. Next, I have to find the measure of arc BC. Well, using vertical angles, angle BOC is 120 degrees. If I have congruent central angles, I have congruent central arcs, intercepted arcs. So the measure of arc BC is 120 degrees. Now the measure of angle DOC. So here we're looking for the measure of this angle. We can find this one of 2 ways. We can use a linear pair and find that it is 60 degrees. Also, we can use the fact that segment BD is a diameter. So 180 minus 120, I get arc DC is 60 degrees. And my arc and central angle must be congruent. Next, I have to find the length of segment BC. Now, again, if I have congruent central angles, then I have congruent chords, and the length of segment BC is 10 root 3. Next, I have to find angle OAD. So I'm going to highlight that, angle OAD. Now, technically, that extends to point C. I should probably go back to drawing and not highlighting. So for part E, the measure of angle OAD. So this is an inscribed angle, and it's equal to half its arc. So the measure of angle OAD is going to be half the measure of arc DC. So the measure of angle OAD is half of 60, which means the angle is equal to 30 degrees. Next, I have to find the measure of angle OCB. So we're looking for this blue angle inscribed in the circle. Now I know if arc DC is 60, arc AB must also be 60 degrees. So for F, angle OCB is going to be half of 60. It's an inscribed angle just like in part E. So that is going to equal 30 degrees. Finally, we have to find the radius of the circle. Okay, we want to find the length of the radius. Now, we could choose any segment starting at O. I'm going to use segment OC. But keep in mind, all radii of a circle are congruent. Let's go ahead and draw in triangle OCB. Now what I'm going to do is I'm going to drop down an altitude so that I get a right triangle. And let's call this D. We previously found that the measure of angle OCB is 30 degrees. The total length of my base, segment BC, is 10 root 3. My triangle OCB is isosceles because segments OB and OC are both radii. Now, if I draw in an altitude in an isosceles triangle, it bisects the base. So segment CD is 5 root 3. Okay, again, I'm looking for my radius, segment OC. So what I'm going to do is use trig. Okay, so for part G here, we're going to use trig. This is my adjacent segment to my reference angle, my given angle. This radius is my hypotenuse. So I'm using the cosine of 30 equals the adjacent 5 root 3 over the hypotenuse, which is my radius. If you remember, when we have our unknown in the denominator, we flip-flop. So the radius is equal to 5 root 3 over the cosine of 30. And when I type that into my calculator, I get a nice whole number of 10. That looks like a special right triangle to me. All right. That's all we have in our notes for 7.3 day 2. Thank you for taking the time to watch, and I will see you all next time.